All right, this is part 2 of our review for the for the first part, chapter 9 test here, and I've got this n squared plus 3 over n cubed minus 5n squared plus 2. It really should boil down to 1 over n, right? So in terms of comparison, I'm thinking of it in terms of 1 over n, which diverges, and since comparison things agree, I'm guessing that this series diverges as well. Again, if this is just multiple choice and I don't have to go any further, then I'm probably just set right there. But if I have to actually prove it out, then I need to do something here. Now, a direct comparison is kind of out the window. I really don't know how to compare whether this is bigger or smaller than that. So let's use a limit comparison. So I'll just take this, this one here, divided by 1 over n, and I'm going to take the limit as n goes to infinity on this. Right? That n flips over. I end up with n cubed plus 3n over n cubed minus 5n squared plus 2. The limit as n goes to infinity equals 1. Now don't be confused. In the ratio test, that means that's kind of bad news, but in the limit comparison, we like it. The limit comparison test says as long as we get anything, any number other than 0 or infinity, then we're doing good. All right, that these two then agree. They do the same thing. So since this diverges and we compared it to it, this will also diverge. So we'd say this diverges by limit comparison to 1 over n. Okay. Number 11, we see we have an alternating series. So right away, I'm going to take the limit as n goes to infinity of the sequence that that alternator is on, and that goes to 0. So I have a sequence that goes to 0 and will get smaller and smaller over time. So this converges by alternating series test. Okay. If we wanted to go a little bit further, we could pull the alternator off and look at 1 over n plus 8, which is very similar to 1 over n. And through a limit comparison, we could see that this diverges on its own. So that series would have diverged without the alternator. The only reason it converges is because of the alternator. So we could say that this was conditional. Okay. Didn't ask us to do that, but that's just a little extra while we're here. Number 12, I've got 5 to the n over n factorial. So 2 different forms there. I have a gut instinct factorial dominates exponentials, so this should converge. But to prove it, I would need to do something else. And I can't compare it to anything else. I can't really do anything like that. So a ratio test is probably a good idea here. Let me take 5 to the n plus 1 over n plus 1 factorial divided by 5 to the n over n factorial. And we're going to take the limit as n goes to infinity on that. Which will be the limit as n goes to infinity on n factorial comes up, 5 to the n goes down, so we'll have 5 to the n plus 1 times n factorial over 5 to the n times n plus 1 factorial, okay? And so that's going to give us the limit as n goes to infinity of, there's 1 extra 5 on top, there's an n plus 1 on the bottom. So as n gets super big, this is going to go smaller and smaller and smaller. It's going to go to 0. So ratio test says if you get that limit to 0, then you're going to have a converging series. This converges by ratio test. Okay. We get 13. 13 is a little odd. We have 1 over n minus 1 over n plus 1. And there really isn't a test to this one. I threw this one on there just to kind of see what you might try to do. You could try to combine like terms or get a common denominator, and if you did that, you'd have n plus 1 minus n. You'd end up with 1 over n times n plus 1, which does converge by comparison, by limit comparison, to 1 over n squared. So you could go that route, but I wanted to show you a little bit kind of a cooler idea here. If you were to put 1 in, you're going to get 1 over 1 minus 1 over 2. Okay, then put 1 in, or put 2 in, and you'll get half minus a third. Then put 3 in, then put 4 in, And what you start to notice is that we've got a bunch of canceling here, and that canceling won't stop, right? That's going to go on forever and ever and ever. The only thing that will actually be left here will be that 1. So this converges to 1. It's what's called a telescoping sequence. You start to stretch it out and you start to see the patterns there. You can actually do it from that. All right, now we are asked to use integral test to figure out what's going on here. Can we do it? Well, this is a continuous function, so that's good. It is a continuous decreasing, and oh goodness sakes, I should have, having a complete blank right now. Good thing I have the book open. And it's positive. Just like me, staying positive here. So this function is continuous decreasing positive. So that all lets us use integral test. What the integral test says is, let's go ahead and integrate from whatever this is to infinity. So I'm going to take the limit as b goes to infinity, which is a little more proper. All right. And we're going to look at this function e to the negative 2x. All right. And whatever this does, that'll be the same result for that. Meaning if this converges, that converges. If this diverges, that diverges. If this converges, this doesn't necessarily go to the same value. It just means that it also is limited. All right. So we go ahead and do this. We're going to get e to the negative 2x and then a negative 1/2 there. Go from 1 to b. We're going to take the limit as b goes to infinity. Which will give us negative 1/2 e to the negative 2b minus negative 1/2, so plus 1/2 e to the negative 2. And we're taking the limit as b goes to infinity. Okay? So if that were to flip down, if we had negative 1 over 2 e to the 2b, and we let b go to infinity, meaning we let this get bigger and bigger and bigger and bigger, then this right here will go to 0. And we'll end up with 1/2 e to the negative 2. So this integral converges to here, okay? So our series converges, but not to this, okay? Converges, I don't know what it converges to, but it's not this. But it does converge by integral test. That we can say. We can't say that it equals this, though. And that's the one thing you got to be real careful about. All right, then we're asked whether these things converge conditionally, absolutely, or diverge. So the first thing you do when you see that alternating is look at the sequence that you're working with, which is 1 over n squared plus 3n. That definitely goes to 0, gets smaller over time. So we know this converges then. With the alternator, that's a guarantee that this will converge. Then what you do is you say, well, what if the alternator wasn't on there? Okay? Well, if I compare that to 1 over n squared, I'm going to be able to use limit comparison test, show that these are the same. This converges. So since this converges, this will converge. So in other words, that series, if it didn't have an alternator on it, would have converged anyway. It didn't need the alternator. So we say this converges absolutely. Didn't need help. It would have been just fine. Okay. If I go to this one here, again, I'm going to take the limit as n goes to infinity of 2n plus 1 over 5n squared minus 9. That goes to 0. So because that's going to 0 and gets smaller over time, we know that this converges. Okay? But now the question is, well, what if it didn't have that, right? And if you boil this down, n over n squared, that's going to be like 1 over n. And I can do a limit comparison test between these two and show that they're of the same magnitude. This is a divergent series, so I'll be able to show that this diverges. In other words, if the alternator had not been on this, this would have diverged. The only reason it converged as this is because of this alternator. And so therefore it converges conditionally. Only reason it converged is because of that right there. We get to this next one, and it says, what if you have a sequence where each term is the term before it times negative 4/3? In other words, you're just going to continue to multiply by negative 4/3 to get the next term, the next term, the next term. Well, negative 4/3, the absolute value of that is bigger than 1. And so these terms are going to get bigger and bigger. I mean, they're going to alternate, but they're going to continually get further and further and further away from 0. So this diverges. We don't have something heading off to 0. All right, we'll do part 3 in just a second.